So here's some ideas for you to simplify. Uh, I mean, to make it more efficient. And I mean, it could be 10 times faster, maybe even 50 times faster if you follow these ideas. Uh, okay, so I told you a million times, don't use solid bodies for shell bodies. So I deleted a bunch of these things. Um, for instance, this thing. So the way we turn this into a shell is you use this mid surface assigned, you click it, and then it becomes transparent like this, which means it's a reference representation, which is it just has the information of where the shell is going to be and the thickness, but you have to then assign it. Oh wait, not there. Probably here, face, offset, and then you click on one of them. Done. Auto select, and then use half the average distance, and now it put a shell right there. And then you go back here and use assign thickness and offset, compute thickness from opposite faces, so that's all default. Okay, and now you have this shell in the middle that has this thickness like that. So when I go back to the assembly, I can see it there, right? The other thing you would have to do would be to assign a shell to this. I think here you can just put any number, and then when you assign it, you say here from geometry, right? So it should look correct. Yeah. Let me just see what it looks like when you mesh it. Sorry. So make it better like that. And then you check here, thickness. It looks a little weird. Looks like that tool is not the best for the section assignment. You can also assign the section directly. Say that I'm not sure what these values are. Let's see. Probably millimeters. So I don't know. I don't know what your thickness is there, but I think there it would look better when you mesh it. Yeah. Looks like your thickness was a little higher. I don't know what that value was, but half an inch or something. Yeah, it looks perfect. And then the other really cool thing that you could do would be to use, instead of having these things with thousands and thousands of nodes, these guys, so then the thing that you can do is to make the reinforcements with stringers. So it's a really efficient thing. What you do is you take the part, say for instance, and suppress that for a second. So when you have this part already as a shell, then what you do is you can create you do a face partition, so that you make the lines that are going to be the reinforcements, and you can do that with a plane. I usually like this 3 points plane, but if you do a 3-point plane with only these points, it's not gonna like it. So you just have to make this point here, which you make it with like this. Okay, and then you select that, and then it creates this plane. And then when you do that, you go to split face with like this, and you just create a partition on that face using this plane. And I mean, if there's a pattern, you can just do a pattern like this, you know, something like whatever you want. Okay, and then it just makes all of these. And then what you do is in the properties, you go to this button here and create stringers, and the stringers are going to be all of these. So you just select all of them, and that's your stringers. You can see them there. Or actually, this previous one is the one I made before, but let me delete it so you can see. So this one doesn't have a section yet, it's just a stringer. And then you just have to assign it, you know. You create a profile with the right cross section, right, the right size, whatever you want. If it's offset from the center of the stringer, then you probably want to use a arbitrary section or something like that. But I don't think it matters too much if it's offset. Or you could make the face offset and leave the stringer where it's supposed to be. Just assign everything the usual way, and then you do the assignment, pick stringers. Okay, and then you have to do a orientation assignment, pick stringers, and then here it could be a little tricky if you use partial stringers. I'm going to use the full thing so you can see. So you pick the whole reinforcement, and it's asking you to orient the box profile with respect to these directions. So you're supposed to provide the in one direction. If I do one, it's like the x-axis here. And so it's going to orient them like this in the way that you drew them here. Right? 1 and 2. Right? So when you do that, it just creates these things. And then in the mesh,
it just makes a really nice mesh. You don't see the elements on this thing, but you will when you run simulation. I already put some loads in there. Let me see. Make another bound condition just to constrain this a little bit better, just so there's more stress on it. And then just run it again. Okay, so I have to go to load and change the load on the button DC1. This, yes, okay, yeah, brown, okay, DC1, yes, cast, this. Aborted. That missing property. Oh, probably this time. Sorry. I'll use set. The way I like to do it is to create a set that selects faces. Okay. So that when I assign things here, I can use sets and so it's linear. That's why it looks a little off there, but the nice thing is it shares the nodes, right? Between the shell and the reinforcement, they share nodes, right? So it just behaves much better than trying to put the thing on with a tie constraint. You could just, for the sake of visualization, like make those things bigger and stuff, which will look a little better like that. And then you probably have to go in and orient them correctly. But it's super fast when you do it like this.